已经解放了，他们已经解放了，我今晚要报复性娱乐了。哇。
I think it's the last time for us to be at the EU right?
Oh, actually 4, that girl was all.
Yes.
对，还有4个人。
真好。
You're the better not.
Make sure you do not block your minutes.
因为待会看你没听，你最好不要干。
Hello everyone. Today I would like to introduce you a striking new discovery that may revolutionize the cancer immunotherapy field, which is the supernumerary proliferation and longevity of T cells, the future of immuno-oncology. So here's the structure of my presentation. I will first introduce you to the discovery, then share with you some prospects it may bring about, and finally talk about some limitations of this study, and I will give a summarizing all of these. So now let's talk about the discovery. Well, for about 50 years, under the stem cells, cancer cells are perceived to be the only cell type that can proliferate infinitely in the human body. Healthy somatic cells can only proliferate for about 50 to 60 times, and after which they will undergo apoptosis, mainly due to the shortage of telomeres and the malfunctioning of mitochondria and other organelles. However, a recent study in immunology breaks this rule, and it could have a significant impact in the cancer immunotherapy field. So now let's look at the overview of this study. Well, it was conducted by the University of Minnesota, and it lasts for 10 years. They found that T cells, which are the immune cells that mature in the thymus, can live for more than 4 times the lifespan in mice. So the study involved injecting the low-potent virus or vaccines into mice for multiple times, and after which then T cells were extracted from the lymph nodes and the spleens of the mice and put into the mice of next generation. And the same vaccines were used to activate the T cells in next generation mice for multiple times. And this whole process is repeated for 4 generations of mice. And they found T cells are still able to fight against the virus even after 51 times of immune reactions. And the average longevity of T cells from the first generation mice is estimated to be 10 years, which is roughly 4 times the lifespan of the organism. So this study could have significant implications in the cancer immunotherapy field. So now let's look at some prospects it may bring about. One such application could be for the CAR T therapy, which is short for the chimeric antigen receptor T cells, which involves genetically modified T cell receptors to target and destroy tumor cells specifically. We can see that in this therapy, T cells are removed from the blood of the patient, and by using the virus vectors to modify the T cell receptors, the modified CAR T cells have more efficient weapons against tumor cells. However, there is a problem. The potency and longevity of those chimeric CAR T cells are not always guaranteed, leading to the possibility of tumor cells still surviving and metastasizing after CAR T cell depletion. So this is where the research we talk about today can help. Mimicking the genetic mutations occurred in T cells in this study could potentially make CAR T cells stronger, although the ways that genes mutate are still under exploration. Well, this research could also improve the efficiency of cancer immunotherapy by informing us that our immunity can be long-lasting if it is correctly activated. You see in this graph, T cells are repeatedly stimulated in a microenvironment filled with cancer cells, and they can become easily exhausted, show less proliferative capability, less sensitive to threats, and gradually become dysfunctional and depleted. Well, reversing this depletion process is pivotal for the efficiency of immunotherapy. And this study tells us that T cells are innate sprinters, but can be trained to be marathon runners with the combination of stimulation and relaxation, which could provide huge prospect for cancer immunotherapy such as cancer vaccine. Imagine if we inject cancer antigen in our body for multiple times with enough intervals of relaxation in the middle. Then what will happen? Our T cells targeting that specific T cells, specific cancer cells will be extraordinarily strong and can prevent us from cancers more efficiently. While finishing the prospects part, let's return back to the ground and talk about some limitations of the study. Well, first, it should be noticed that this study currently has only been conducted on mice, and its applicability on humans is still need to explore. And second is that, our immune system is complex, right? Even minor deviations in cytokines could induce unexpected effect. Therefore, the application of this study in cancer immunotherapy field may still face significant challenges, and it still take a long time to implement it in real-world scenarios. So to summarize, the supernumerary proliferation and longevity of T cells may provide a tremendous prospect for cancer immunotherapy, such as RT therapy, cancer vaccines, etc. However, due to the extreme delicacy of human immune system, its real-world application still needs a long way to go. And here are my references. Thank you for listening.
这个简直可爱，这是含义。
啊？